Hello YouTube. This video is about driveline angles. We have 5 and we'll talk about terms right now. The center line of the motor is one angle, and that's how far the motor is tilted up or down. So the center line of the motor is one angle. Drive shaft angle is another angle. And the center line of the pinion shaft is another angle. Those are angles that we can measure. The universal angle at the front and the back are calculated angles. And we'll start that. But before we start, you should know that the vehicle should be at ride height and should have all the weight on it. Now obviously I don't have all the weight on it, but I want to see where this drive shaft, approximately where this drive shaft is going to end up before I start building the car. We need to be able to take accurate measurements. So you're going to need a digital protractor. You can get those at Amazon or Lowe's for about 20 bucks. It has to be accurate within 1/4 of a degree. These are accurate within 1/10 of a degree, so they work really nice. So the first angle we're going to do is the center line of the motor. The center line of the motor is the crankshaft. So this harmonic balancer is bolted directly to the crankshaft, and I find this to be the most accurate way to get the angle of the center line of the motor. If you have the pulley already on, you can take a straight edge and put it over the edge of the pulley and then take your measurement that way. So this measurement is going to go like this. And we have a measurement of 3.9 degrees down. By down I mean the back of the motor is tilted down when viewed from the side of the vehicle. And we'll go take our next measurement. The drive shaft angle is 6.8 on my lightweight flexible drive shaft. Now we need to get the angle of the center line of the pitman shaft, and that can be difficult as there is not a flat surface on a typical rear end. This is a fabricated rear end, the top of it's flat, but I don't even trust that. So what we're going to do is we're going to remove the universal and drive shaft, and we're going to take a straight edge and put it across the front of the yoke, and we're going to take our reading that way, right there. And the reading is 2.2 degrees down. Now we have to talk about that direction a little bit. We just took a reading of 2.2 degrees down on the center line of the pinion shaft. What's that really telling us? Well, if I take a protractor and it's at 2.2 degrees down, and I don't know what's saying, it doesn't make any difference, I'm going to exaggerate. So 2.2 degrees down, and we put a ruler on that to extend it for the shaft of the pinion, we find that what's really telling us is that the back end of the pinion is lower than the front end of the pinion. In fact, what we have is an increasing angle to the front. So even though the digital protractor says it's down, and it is down, it's down towards the back, it's up towards the front, so the angle is up. Here are the values for the angles that we measured on the car. You did write them down, right? The center line of the motor was 3.9 degrees down. The drive shaft angle was 6.8 degrees down towards the pinion. And the center line of the pinion shaft was 2.2 degrees up towards the motor. The way you calculate your universal working angle is if both angles are the same, down and down, 3.9, 6.8 down, so they're both going the same way, you subtract the smallest angle from the largest angle, and you get 2.9 degrees of a working angle for the front universal joint. Now, for the rear universal joint, the pinion shaft is pointing up at 2.2 degrees, and the drive shaft is sloping up towards the motor at 6.8 degrees. That's a little confusing. Understand what I'm saying? The drive shaft from the pinion to the motor slopes up. So in this case, the drive shaft is sloping up at 6.8. And we have both angles going the same way again. We've got 2.2 on the pinion and 6.8 on the drive shaft, so the angles are going the same way. So we subtract the smallest from the largest, and we get 4.6 for our working angle of the rear universal. So what does all that mean? It means it's terrible. What I've got is bad, bad, bad. This angle right here and this angle right here should be the same. You want the center line of the motor and the center line of the pinion shaft to be parallel to each other. Not pointing at each other, but parallel to each other. The center lines of the crankshaft and the center line of the pinion shaft have to be parallel to each other. So these angles should be the same. Next is 3.9 degrees down on the motor is beyond what you would typically find in a passenger car. Passenger car would be about 3 degrees. This is going to be a gasser, so I'm going to have to probably accept 3.9 degrees or more. Center line of the pinion 2.2, that's got to match the center line of the motor. A working angle of a U-joint of 2.9 is acceptable for a passenger car. This is going to be a drag car. We want this angle to be as small as possible. That universal should work at 0.5 degrees to 3 degrees. And we're 2.9, so we're inside that. But we want to decrease that. And 4.6 is way outside. So we got to work on that a lot. How am I going to work on it? Well, I'm going to increase the center line of the motor. That'll increase this angle, which means I will be taking more away from the 6.8 of the drive shaft, which will decrease that number. And I'm going to have to increase the center line of the pinion shaft quite a bit so that we can get them parallel to each other, and then that number will be the same. I've made some adjustments. I have the engine hanging from an engine hoist. And basically I've dropped the back end. The front end is where it was. It's still on the motor mounts. And now we have 4 degrees of down on the motor. We have a drive shaft angle of 6.1. I adjusted the 2 upper bars of the 4-bar system. I expanded it so that it would rotate the back of the axle backward, which would bring the front pinion angle up. And now we have an angle of 4.0. Let's take a look at our most recent measurements. The center line of the motor is now 4 degrees down. Drive shaft angle is now 6.1 down. Drive shaft angle changed from 6.8 to 6.1 because the motor is angled down more and the pinion is angled up more. The center of the pinion shaft is angled up at 4 degrees. So using the same rules that we used before, with the angles going down, we take away the smallest angle from the biggest angle. We end up with 2.1 degrees is the working angle for the front U-joint. And the drive shaft is 6.1 and the pinion angle's at 4. So we got 2.1 for the working angle for the rear U-joint. The only angle that's really out now is these 2 angles right there. Now, the norm for the center line of the motor is about 3 degrees down. So that's not terrible. And norm for the center line of the pinion shaft, I couldn't find any norm. But they've got pinion shafts and 4-wheel drives as high as 12 degrees. So I'm not concerned about this at all. These working angles, 2.1 is within operating norms. They want you to be anywhere from 0.5 to 3 degrees. For drag racing, they want to be as close to 0.5 as you can get. So let's take another shot at it. Let's try 5 degrees down on the motor. The drive shaft angle is now 5.5. And we have 5/0 on the pinion angle. Here we have the results where we achieve the 2.1 degree working angle for the U-joints. We have changed the center line of the motor to 5 degrees down. That changed the drive shaft angle to 5.5 degrees down from the 6.1 degrees down that we had on the last pass. And the center line of the pinion shaft is now 5 degrees up. Using the same rules where you take the smallest value from the biggest value when the angles are going in the same direction, and that's for the motor. We have 5.5 on the drive shaft, we have 5 on the motor, we end up with 0.5. And the same thing is for the rear U-joint. We take the smallest value from the highest value. The drive shaft is at 5.5 up from the pinion, and the pinion is up at 5. So we end up with 0.5 on the working value for the rear U-joint, which is excellent. We've come a long way. We started with a drive line that had angles that were way out of whack. And we dialed that in pretty much perfect. The only angles that are not within the norms are the tilt of the motor and the tilt of the rear end. Now, the tilt of the motor is at 5 degrees. And they say, and everything that I could read, that the tilt of a motor generally is 3 degrees in a passenger car. I did not read anything that said there was harmful effects for tilting it further. And I'm only going down 2 more degrees. With the rear end, they have these rear ends in Jeeps with 12 degrees on, so I'm not even going to worry about it at all. But it has caused pain in other departments. Let me show you. As you can see, my pretend drive shaft is smaller in diameter than a normal drive shaft and is already too close to the cross member. We're going to have to modify this cross member and reinforce the top so it becomes our front loop for drag racing. We have the same problem with this rear drive shaft loop. The drive shaft is too close to the bottom of the loop, so we're going to have to remake this loop. When you take your final driveline angles, you want the vehicle to have a full weight on the chassis, and you want the tire sitting on level ground. If the ground is not level, it will affect the drive shaft angle, which will affect your readings. I don't have the weight on the vehicle right now, so that's going to affect my driveline angles when I put the weight on the vehicle. So I will have to do this again. I hope you enjoyed the video. There'll be more.